Hello everybody, we're going to be working on section 1.1 of our homework today. Our goal is to get through this and help you understand the ready, set, go, all the three sections of the homework to better prepare you for our eventual quiz and to just understand these topics a bit better. The first section is on inverse operations, and inverse operations undo each other. For instance, addition and subtraction are inverse operations. If you add a number and then subtract that number, you've undone it, you've done nothing. And they're called inverse operations. So are multiplication and division. And so in mathematics, it's often convenient to undo several operations in order to solve for a variable. And that's exactly what we're going to be doing here. We're going to be looking to solve for x in the following problems, and then we're going to complete the statement by identifying the operation you use to undo the equation. So we're going to look at each of these problems, we're going to solve for x, and then we're going to put it into words, because one of the things I really value is articulating in language the exact things that we're doing. So to do that, let's go ahead and look at number one here. Number one says 24 equals 3x. So it's going to be important for us to undo that operation. So when we're looking at it, we want to look at 24 equals 3x. And then what do we do to undo this operation? Well, we want to get x by itself. To undo that, we would have to divide by 3. When we divide by 3, 24 divided by 3 is 8. 3 divided by 3 is 1. That's why we did it. It's undone now. And so 8 equals x. So we know that x equals 8 here. But what did we do? Oh, that's an ugly looking 8. What did we do? Undo multiplication by 3 by, well, what did I do? What was this step? How would you say what this step is? Well, what I would say is by dividing by 3. Okay. Let's do the next one. The next one wants us to undo division by 5, or undo division by 5 by. So we have x divided by 5 equals a negative 2. How do I undo that? I multiply both sides by 5. X equals negative 10. So this would be x equals negative 10. Undo division by 5 by multiplying by 5. That's it. So go through all of these. Some of them get a little tricky when you're looking at square roots, right? If you want to undo the square root, what do? You're going to have to square it. If you want to undo the cube root, you're going to have to cube it. And so make sure you're paying attention to those things when you do that. All right, let's go ahead and go to the next topic. The next topic is the set. We're going to be looking at linear functions and their inverses. So we have this very long problem here, right? And take your time with it, and let's look for what's going on in this problem. It says, Carlos and Clarita have a pet sitting business. When they were trying to decide how many each of dogs and cats they could fit into their yard, they made a table based on the following information. Cat pens required 6 feet of space, while dog runs required 24 feet squared of space. Carlos and Clarita have up to 360 feet squared available in the storage shed for pens and runs, while still leaving enough room to move around the cages. Okay, so all that means is that we don't have to factor in walk space. That's already factored in to the 6 feet squared for cats and the 24 feet squared of dogs. They made a table of all the combinations of cats and dogs they could use to fill the space. They quickly realized that they could fit in 4 cats in the same space as 1 dog. And here's the table. 15 dogs, 0 cats, 14 dogs, 4 cats, etc., all the way to 60 and 0. Okay? So that's understanding our problem. So let's look to see what our questions are. It says it wants us to use the information in the table to write 5 ordered pairs that have cats as the input value and dogs as the output. So when we're talking about input, output, this goes back to my classic idea of the function machine, right? The function machine. We have input, and then we have output, and this is our function. It's important to note that our input will always be x, and our output will always be y. Okay? So this is an x, y pair. So when it says use the information in the table to write 5 ordered pairs that have cats as the input. Cats as the input means it needs to be your x value, and dogs as the output means it has to be your y value. So essentially you're looking for 5 places where you're going to put cats, comma, dogs. Okay. So looking at our table, 414, cats, comma, dogs. 2010, cats, comma, dogs. Input, output. Okay, so do that a few more times. And then each of the following questions will build on that. It says write an explicit equation that shows how many dogs they can accommodate based on how many cats they have. Okay, so we're going to have to look at our equation to figure out what that is. And so we do know that it takes 6 feet per cat, and then it takes how many feet per dog? 24. 24 per dog, and that equals 360. And it says we want to be able to figure out the number, dogs D, cats C, did that. D equals F of C. Okay, so we want to figure out what F of C is. So what we want is our input to be C, and then we want to figure out how many dogs that is. So where we have dogs, we're going to put F of C, because the number of dogs is going to be a function of the number of cats. So 6C plus 24 F of C, let me write this, equals 360. And now all that you have to do is get F of C by itself. Subtract 6C. So we get 24 times F of C equals a negative 6C plus 360. Divide by 24. Divide by 24. F of C equals 6 divided by 24 is negative a fourth. C, and then 360 divided by 24, off the top of my head, what is that? 15 plus 15. And so that's going to be our equation. Okay. And then go through the next steps and answer the following questions as it gets a little bit more complicated. But setting up this equation seems like one of the more challenging bits. So go ahead and watch this again if you need to go through that process. Finally, we have our go section. And what this is asking us to do is to use function notation to evaluate the function. So we're given 3 functions. We're given f of x, we're given g of x, and we're given h of x. And so what it's going to do is it's going to give us different values in 14 through 25 here, and we got to figure out exactly what that is. So this is f of 10. So f of 10 equals, well, x is 10. So f of 10 is 10. Done. F of negative 2. Well, this is going to be f of negative 2 equals, what's our x? Negative 2. So negative 2. Done. F of a. So f of a, and this one's a little bit different because we're given a letter instead of a number, but we're going to do the same thing. Instead of x, when we were asked to put 10, we put 10 in for x. Instead of negative 2, we put negative 2 in. Instead of x, we're going to put an a. So a will be our answer. And then look at this fun one, f of a plus b. So that's going to be f of a plus b equals, well, a plus b. But things get a little bit more interesting when we look at these other options. For example, let's look at number 18 real fast. Number 18 asks us a g of 10. So if g of 10, what do we do differently? Well, we don't really do anything differently, but all we're filling in for is that x. So this is going to be 5 times 10, right? Because it was 5 times x. Now we're going to say 5 times 10, and then minus 12. So we got to do a little bit more arithmetic. 5 times 10 is 50, minus 12, and that's going to be 38. Okay, so go ahead and grind through those problems. Get used to using this function notation. Know that this is the input. Input, we get our output. Input, we get our output. So keep that vocabulary in mind, and I will see you all tomorrow. Good luck.